Hey everyone, my name is Michael Dang. I'm an engineer on what we call the mobile developer infrastructure team at Airbnb. And today I'm here to talk about Android CI at Airbnb. I just want to kind of provide some insight on the kinds of things we do in CI that's specific to Android, as well as kind of our history and journey to show what we built out today. So a little bit more about myself. I've been at Airbnb for 3.5-ish years now. I worked on product for about a year and a half. And have been working on these kind of like build tools and CI for the past 2 years now. So this is the Android team in 2015 when I joined. There's 15 of us here. And yeah, so I worked with this team for a year and a half, and I've been working on the infrastructure team now just to help support these amazing guys because I really want to make sure that these guys have a great developing experience. Aside from that, I'm also a man of many hobbies. If you don't want to talk about CI or Android but want to chat, feel free to come up and talk about photography or climbing, video games, mechanical keyboards, Super Smash Brothers, lots of other stuff. Cool. All right, so let's get started on exactly what is CI and kind of the part that I'll be talking about. So this is maybe like a diagram of a typical engineer workflow involving CI. You write some sort of code, and you push it to your source control server. We use GitHub Enterprise. Then you open up a PR, which will then trigger a series of builds and tests and then notify you about whether it actually succeeded or failed. This is the part I'm going to be talking about. This part is CI. And what are some examples of CI then? Well, there's a lot. There's TeamCity, Travis, Circle CI, Buildkite, Jenkins, Avere, GitLab, Hudson, Bamboo. There's a lot of different versions of and tools you can use for CI. This isn't going to be a talk about which one's the best or even the best for Android, but just to give you some insight on what we decided on and which factors went into those decisions. And so I want to go a little bit into a short history of Airbnb. I think our mobile team is fairly new compared to some other companies, but I want to help paint a picture of like how our mobile team's growth has affected the kind of decisions we made. So in 2014, we had 15 mobile engineers, so that's about half on each platform, 7 or 8 on iOS and Android. There was no CI. We did have 3 Mac Minis set up on a stack to build the iOS release app, and the Android release app was still built on someone's computer. So this is the state of things. It's pretty raw, very startup-esque, super small team. And so what happened if Master was broken? You yelled at them. They were probably sitting in a desk or 2 away from you, and so you just found the engineer who broke it. They'll probably fix it. Life moved on pretty quickly after that. And in 2015, which is the year I joined, we grew to 30 mobile contributors, so about 15 on each platform. We actually implemented CI, which is TeamCity at this point. We decided this because it's actually what we used to build the iOS release app. So we just built on top of it, went full throttle, built out a whole CI infrastructure with it. And at this point, we're doing builds on PRs. We're running master after every commit is merged. And we also have some release automation stuff for both platforms now. We have 30 build agents total. So about, I think, 12 at this point, maybe 12 later on. But at one point, we have around 12 iOS agents because iOS app has to be built directly on like Mac OS and all that, which would be important a little bit later, even though this is droidcon. And then the rest are Android, which was actually really easy for us to scale because we did everything through Chef on like EC2, Amazon instances, so you can easily scale it at a press of a button. So in terms of scaling there, it wasn't too much of an issue for Android. The TeamCity server was actually also managed by us mobile engineers. So our infrastructure team was helping support the other parts of Airbnb, and we were kind of left out our own here. So we decided to go with TeamCity because that's the one we were comfortable with at the time. Cool. So in 2015 to 2018, so from then to now, I just want to point out that one of the main factors for our CI infrastructure's direction is the growth that the mobile team experienced. For a couple of years, the number of mobile engineers was actually doubling in size. And so this growth actually led to a verticalization of our mobile teams to verticalize on the feature teams. And this just made overall communication and collaboration more difficult. As you can imagine, since we're no longer sitting together, you just have like, less interaction with other Android engineers. And so this meant that we had to focus more on stability and enforcing higher standards in our code base to ensure that the development experience doesn't degrade over time as we have more engineers. Right, so to quantify this, I think from this period, we actually grew about 5x. We're close to 150 mobile contributors. Maybe about 120 of them are full-time. We have some web folks who help contribute. We also have a monorepo of our Android, iOS, and React Native code. And as you guys probably also know, we added and are subsequently sunsetting React Native. And we also added several more jobs to CI and for release automation. We're no longer just building stuff for PRs and master, but we're doing things like we're building multiple types of builds. We have like UI tests, we have unit tests. We even generate some documentation now. We have Android lint, etc. We're also not just building the release app, but we're actually scheduling uploads of our alpha and beta just to remove some tasks that the release manager would normally have to do. And we've also moved over to Buildkite. So our current CI tool is Buildkite, no longer TeamCity. We'll get into that later as well. And now we're close to 250 build agents. So I'm not sure if you guys were here for Gautam's talk about Uber CI, but yeah, we have racks of Mac Minis that we personally manage, and it's kind of a pain in the butt, but this is where we're at now. So close to maybe 2 to 1 or so, 1 to 1 build agent per mobile engineer. Cool. So I'm going to just dive into some specifics about TeamCity, kind of the problems we ran into and why they were an issue for us. This is going to be very specific to us, but maybe if some of you guys have run into similar problems, you guys can empathize a little bit. But just to start off, this is how it looks like to add a step in TeamCity. I think it's fairly easy. There's this drop-down form-style UI they can use to define a new step. The downside of this that I will detail later on is that mixed with the fact that there's actually no sort of code review for any of these changes. If a lot of your build logic actually lived in TeamCity itself, you probably had high potential to break something if you made a change. So we'll get into that a little bit later as well. But all in all, fairly easy to add a new step. This is just an example of showing a drop-down menu with some predefined parameters that we filled out. These are some like secrets that we put in, and you can easily reference them. There's also an idea of like build inheritance. So this allowed us to easily add certain kind of universal steps to any sort of build, like analytics or alerting with like some sort of event. And so what are the reasons for moving off? So this is actually the biggest reason, limited PR reporting functionality. So this is kind of hard to explain, but it involves basically a build queue when you don't have enough agents to run all the PRs that want to be built. And so yeah, around 2016 or so, I think we had 12 agents for some 30 iOS engineers. And again, while this is related to iOS, it was definitely part of the decision for us to move as a mobile team. And so I think the next images will help illustrate this. So back to this photo, the part that was breaking is actually step 6 here, notify success or failure. So you expect that if you open a PR on GitHub, it'll kind of show in the status like whether it's pending or finished, and whether it succeeded or failed. The pending part is what got to us. So this is just a screenshot of like 16 builds in the queue. So for a bunch of these builds or PRs, the builds haven't started yet. What you expect to see on GitHub is something like this, right? Things are waiting, things are yellow, that's fine. You move on with your life, and you get back to this later. The weird thing here, though, is that this is what people are actually seeing. Everything's green, even though nothing's ran. Why? Why do you do this to me? And so this was just kind of like a weird functionality, I guess like bug in TeamCity. This is, of course, of like a very old version of TeamCity, like 2017.1.1. Maybe these things have changed since then, but it kind of, for the time, this is actually one of the biggest things that caused a lot of headache for us. People would come to the screen, see that their PR was green, and they would merge. That would cause like master to break because no builds or tests were actually running. And so we wanted to be able to fix this. So aside from this, continuing on, there's a few other things. This user experience that I mentioned before about like configuring everything within a UI can be not super scalable if you have really complex build configurations, especially with like the inheritance and like lack of code reviews. It's really easy to break something basically. And that in hand that we didn't have any support from our local infrastructure team and that everything was on the mobile engineers just added too much overhead for our team. That's that point there, mentioning that. And the rest of the company was on Travis and Solano. So, there's 3 different build systems going on, kind of maybe too much for us to handle. The last thing, that's more of a funny story than anything, TeamCity is not emoji friendly. So we've had like company-wide incidents caused from emojis. One of them was a fire emoji, which is funny. But here's just an example. Basically, all of TeamCity was red. Everything is failing. We saw this weird failure. Wasn't really sure why. Then we saw this guy. So it's funny because TeamCity can actually render this. But then there's a SQL exception saying it can't insert it into a database. We weren't entirely sure about what was happening, but our guesses were that like TeamCity was fetching from our GitHub repo and then kind of doing like some sort of indexing on all the files. And I guess when it got to the emoji file, it just blew up. Everything went red. It was pretty crazy. But we were able to fix this, but this is just kind of one of those funny stories where you don't expect emojis to create like company-wide blockages. Yeah. All right, so moving on, I'll introduce Buildkite now and about why we wanted to move to it. So around 2017, we transitioned our Java and mobile repos to Buildkite. This started as an effort to find a solution to the problems we were encountering about TeamCity and Travis, although I don't know the exact details about Travis. But this was also just a way for us to start anew and kind of with the knowledge we had from our previous learnings to manage our new CI tool. Cool, so what are the big wins from Buildkite for us? So yeah, like I mentioned, that PR reporting thing worked great with Buildkite. If your build was queuing, even if nothing was ran yet, it would show on GitHub, it was yellow, and people stopped merging on top of master. There's that. And the flexible build configuration. So Buildkite actually allows you to write a configuration YAML file to have all the specifications you need. And that was just a lot easier for us to handle. You can actually code review everything because all of the configurations lived in your repo, so it's a lot safer in that way. And so anything change you made was actually tested in a PR, right? If you're changing that specific pipeline for that build, once you open a PR, it'll actually be tested, which is really, really nice. And so this probably was possible in TeamCity, but it was still very hard to test changes if a lot of your logic actually lived in TeamCity rather than a configuration file somewhere. Buildkite also automatically parallelized jobs. Again, I think this is one of those things where it's possible in TeamCity, but Buildkite just basically gave it to you for free. So that's really important for us because not all everything's needed to be run serially. And a few of the smaller wins, we think it's a nicer, simpler to use UI, as simple as that. And the main server is maintained by Buildkite. Maybe this is a bigger win than I'm mentioning here, but we actually have a dedicated support team with Buildkite. It's really easy for us to connect with them, and they'll report any incidents, any sort of issues that they have. They'll be able to work on it directly, which is great. For example, since we were managing our own TeamCity server, we would often run out of disk space because all the logs would be saved on that single server machine. And so then we have to start thinking about scaling and all that stuff. And just as another headache, this is a great thing to have to be able to have Buildkite manage the main server for us. So this is just an example of a Buildkite pipeline, way simpler and less configurable, I guess, in a way than TeamCity, but kind of hard to mess up. Basically, all we do here is that we just upload our configuration file, so no logic actually lives in Buildkite for us. It all lives in our repo, which is really, really nice for us. And this slide here just shows kind of an example YAML file. So this isn't going to be like a Buildkite tutorial or anything, but just kind of show little snippets here and there to show how we use it. Highlighted in red is what we call a job. There's two jobs here, one for Gradle, one for Buck down below. And so these are all run in parallel. In purple, you see the list of commands. So we simply just, in this case, cd into the Android directory and then invoke Gradle to run some builds. In blue, you can see some parameters to enforce the type of agent that we want the build to run on. Since all the builds are under one account, we have all of our iOS agents, all of our Android agents, and some Java-specific stuff. We just want to make sure that we're running the builds on the correct agent, so that's in the proper environment. So this is really easy to configure as well. But yeah, so everything is in a single configuration file, and it's all editable, within your repo and super flexible. All right, so next I want to give an overview about the kinds of things we actually run on CI. I think these can be interesting to show where we put our focus on and what we decided to be the most important tasks to be stable for our Android developers. I've also put release automation instead of CD because we can't really actually continuously deploy, given that we go through Google for Android and Apple for iOS. But I'll show those tasks later. Cool. So in every PR, we do the following stuff. I'll go into them in more detail in the following slides, but this is just the list of jobs that we do. So we build the Airbnb app. We make sure it's buildable, no compilation errors. That does that. We run Android lint for any sort of resourcing, lint errors and stuff like that. We also run UI test, again, to why there's only test later. And we also run some Ruby tests. I'll explain why we have Ruby. And we also have some DLS tests, which I'll explain later as well. Maybe you guys have heard of it. I think we've written some blog posts on it, but it's essentially what we call our design language system. Every job is run in parallel, by the way, so we can get into the bottlenecks and stuff later. Cool. So to build the app, we actually build the app in 3 different ways, maybe 2.5, depending on how you count it. But the first way is Gradle. So we use Gradle because it's the Google-approved method. We actually use it to release. So every release build is built with Gradle. And it's fairly stable. They're consistent builds. But the problem maybe is that it's kind of slow for us. So we actually use Buck and OKBuck. OKBuck is actually something that Uber wrote to help convert your Gradle files to Buck files, so you don't actually have to manage two complete build systems. And we use it because it's faster. That's about it. Buck is super optimized for build speeds. So this is what all Android engineers use for local development at Airbnb. And the last one is what we call Airbnb light builds. So it's actually something where we take advantage of flavors to build kind of smaller, usable portions of the app. Basically, for example, if you only work on messaging for any given day, you probably don't need to build out like the listing page with your compiled app, right? You just want to test your messaging features. So we built a system around this so that engineers can only compile what they actually need. Android lint is a big, but what we think is a necessary pain in the butt. And so we use Android Gradle plugin 3.2.0. One thing to note is that I believe in 3.1.0, this actually included linting on Kotlin files. And we think that that's what is causing our 2.5 full linting time, 2.5 hour full linting time, which is a bit absurd. So we think it's related to Kotlin. As we've added more Kotlin code, this has been slowly increasing. So this current solution that we've come up with to tackle this is what I call smart lint. It basically does like a per module linting. So we detect the changes that you've made on your PR, and we only run lint on those specific modules. So far, this has been proven to be pretty good. I think the average run time is now around like 20, 25 minutes, depending. Obviously, it can vary a lot depending on how many modules you touch. But so far, we haven't seen a scenario where the full 2.5 hour lint has caught something that smart lint has not caught. But this has only been running for a few weeks, so we'll see how it goes. But so far, it's pretty promising. We do also do other Kotlin linting. We use a couple of libraries called KT-lint and detect. This stuff is a lot faster, but doesn't encompass as many lint rules as the full Android lint does. UI tests. So yeah, really, really hard to get it right for us. This is also another point that we spent a lot of time on to get right. And we've had a few heartfelt attempts, but in the end, we've kind of had to nix a lot of those. So to get into a little bit more, one thing that we tried to solve for one of our biggest issues was the idea that UI tests can be dependent on our API servers and everything being up and running. And so it's really frustrating for an engineer if their PR is blocked because like the API went down. So we came up with this tool called OKReplay, which I think we've actually open sourced. And it's basically this tool to record API responses and then deliver those in the context of a UI test so that your tests aren't actually dependent on any servers being run. And so they can actually be mocked through OKReplay. While this was great, there were still a few issues with like rewriting the recorded responses and overall ownership of the tests. I think the infrastructure team actually wrote out kind of a lot of the initial tests. And so when something broke, we couldn't really depend on the other teams to fix it. And overall, this just became like way too much overhead for our team, and we ended up nixing a lot of it because it was just too much for us to handle. But currently, we have one UI test. It has caught a few things. It opens the app and it makes sure that you can see the login screen. And it's caught stuff, so it's useful. It's easy. We don't have to change it, and that's great. But that being said, 2019 is supposed to be the year of tests. We actually have a lot of product teams who are super passionate about this now and are stepping up to take ownership. So this is going to be really great for us. And hopefully we see a lot of major improvements here soon. To kind of do a spiel about Mavericks. So Mavericks is an open source library that we've released. It basically makes it really easy to write Android screens and takes out a lot of the boilerplate with it. And so this should overall make it easier for us to write UI tests and make engineers a little bit more passionate about like having to go and write a UI test and ignore a lot of the stuff that used to be really hard about it. All right, so I want to go into a little bit about Ruby. We have some Ruby scripts to make it easy for engineers to create modules. Just having more modules makes it faster to build with Buck since it parallelizes everything. And so we just have like some scripts to generate directory, add like a build.gradle file with your dependencies that you want, and maybe add some like Dagger stuff. This is also related to like the Airbnb light builds I mentioned earlier. But essentially, long story short is we have some Ruby scripts to help make some tasks automated. And so we want to make sure that those are running as well. So we run Ruby RSpec, which is their testing framework, as well as RuboCop, which is like a stylizer. And so yeah, we use it for some code generation as well as some release management tests. But just another one of those things where you might not think about it, but it's important to have tests for. And so before we move on, I want to talk a little bit more about that DLS system I was mentioning earlier, just to give you guys a little more context. So design language system, that's what DLS stands for. I'll refer to it as DLS from now on. But it's essentially a discipline agnostic collection of view components. It's like a way for engineers and designers to be able to like speak the same design language. Essentially, it fixes the problem of multiple designers recreating a similar component for multiple use cases with like varying one-off designs, and you're copying and pasting the same component or adding some conditional to show a different specific view. And so, this is obviously not that great, not that scalable. You're not sure if you can reuse the component or not. So we developed a system so you can have the same set of rules for all engineers and for all designers. And so yeah, this just means less duplication for us. And as you can imagine, a system like this actually requires a lot of upkeep. We want to make sure that the components across all platforms are equivalent, and that a change to any one component for one screen doesn't break the user experience on other screens. So just to kind of give you a visual example, this is fairly old, but I think it's illustrative. You can see like different types of cards, different types of rows. This is like what we call a marquee, which is like a big header at the top of a page. And so if you wanted to compose a screen, it might look like this, where you have a marquee at the top, some series of rows, maybe a section header to break off important sections, and maybe some more rows. So this is like this huge system that we built out at Airbnb. It's super essential for the developer experience. And as part of CI, we want to make sure that this works, and this works well. So for one, this is actually what we run in CI. We have a browser app that contains all the components that an engineer can build at any given time. And so we want to make sure that this browser app is stable, so we build it. We actually render and show differences with this tool called Hapo. Hapo is this CLI tool used to like diff UI, and it's what we've used to basically capture any differences between a change to make sure everything's intentional. Since a component can be used in multiple parts of the apps, you have to be very, very cognizant of that. We also generate some documentation for DLS, I believe. And we also do very, very specific stuff that may be out of scope for this talk, but there's a lot that we do to ensure that our DLS system stays like stable for all of our developers. Cool. So for our release process automation, we have a weekly rotation of release managers. So we release on a weekly basis, and their job as a release manager is to basically check crashes, make sure the app is stable, merge any sort of cherry picks for fixes, and also like updating translations. This can actually be a very time-consuming and tedious task, but it's also very important. So we try to make as much of it as like automated as possible. So yeah, for one thing, we upload strings for translations. So we actually have an internal translation team where we periodically upload all of our untranslated strings and download any new translations on a daily basis. And we do this on a daily basis because we have scheduled builds and uploads of alpha, beta, and QA. So we actually build and upload an alpha build every 6 hours. And for beta and QA, we build it once a day. We send our QA build to our QA team, and then beta is uploaded to the beta track. We also alert engineers about new crashes. So this is probably one of the most important things I would say about the release manager job, is to actually triage or detect and triage new crashes. So we use a tool called Bugsnag. I think they're actually upstairs. And so for a lot of release managers, like this task can be very cumbersome. It's also like prone to human error when you like don't find or don't notice a crash is like super high priority to fix. And so we built a tool where we essentially will detect all new Bugsnag crashes that occur for a new version, go through the stack trace, try to determine who's the most likely person to have potentially caused the crash, assign it, and then alert them via Slack. So this has helped a lot with just like our app's crash rates and taking off some of that manual task work from the release manager. We also create release branches. So kind of for that weekly release cadence that we have, we basically just take a snapshot of master, name that as the release for the following week. It soaks for a week. We'll do some QA testing, make any cherry picks for the crucial fixes. In this case, we actually use OctoKit to interact with GHE. So I think the long story short is that you just really utilize your APIs for this that are super useful for making things automated and fast. We actually run all these things on CI, so or through Buildkite, our CI tool, just as like a scheduler essentially. So it's like a neat way to utilize it. Cool. So just to go into kind of the future work, as you can see, our CI and tooling is pretty coupled with a lot of different products. While CI, I think, starts at build stability, it can continue with building new tools to improve efficiency, especially with mobile, whose deployment process is fairly complex and is not completely under control. So it's important to have every step in between to be like robust against potential API changes. But in terms of future work, I think one of the more impactful things we could start off working on right now is like a proper release dashboard that just makes mobile development more accessible to everyone in the company. So like there's different groups of people who want different builds. A PM might want a specific branch that's like pre-production ready. Customer service might want a specific app version to reproduce an error. API engineers might just want like master build so they can test their API changes. But yeah, so there's a lot of different groups here. Right now, for us at Airbnb, there's actually no way for this to happen super easily. You have to just ask an Android engineer who will build the app and send you the APK your way. But this would be great if it was more streamlined, just make it more accessible for everyone outside of the mobile engineers. Something else that would be really interesting would just have a dashboard to monitor crash rates, be able to modify A/B experiments, and have some like automatic rollout or halting of releases, which is what we don't have right now. We do it manually. It's up to the release manager to detect these changes. Build visualization is also something that's really interesting to me. As the product grows and engineering becomes more detached from the build tools at work, it's important to make sure that engineers have all the tools necessary to understand and act upon build errors. You saw earlier that we have Gradle, we have Buck, we have OKBuck, we have Airbnb Lite. There's a lot of steps in between for an engineer when they're running code to like seeing it on the app, right? So I don't think we can fully expect every single engineer to understand how every single tool works, which I think would probably be necessary in order to debug certain kinds of errors. So I think we can have some space here to work on kind of confronting these errors and maybe even suggesting certain things you can do to make it easier for them to fix it and debug it. Yeah, essentially make it easier for engineers to understand their build issues. And as I mentioned before, UI testing is going to be the big thing for 2019. I think our infrastructure probably has a lot of space to grow to make sure that everything is super stable for them, and that's really easy for them to develop for this and not have to think about the infrastructure in terms of UI tests. And so, yeah, we think there's a lot of work here that can be done as well. And there's probably more that we can do, but currently my team has 2 people, one for iOS and one for Android. That's me. And so we'd love to get some help from anyone if anyone has any experience here. But yeah, thanks so much. That was my really fast talk on Android CI. I just want to open it up for questions now from the audience. Yeah, so the question was, we were on TeamCity and Buildkite. Why did we decide to go to Buildkite instead of Travis? So for one thing, the team was also looking to get away from Travis as well. And so we together went towards Buildkite. I think one of the things, I'm not too sure about the specific details here, but having the Mac OS support is really important for us to have like a tool that works on Mac. And so we just thought Buildkite is a great option for that. Yeah. Saw a question over there. Yeah, blue. Sure. Yeah, so the question is, why did we decide to have a single monorepo for all of our mobile source code? Basically, I think the biggest reason was probably React Native. So when we decided to go with this, I think in 2016, it also made a lot of sense to have our React Native code share with our iOS and Android. So we decided to make it a monorepo. Maybe that will change in the future as we start sunsetting React Native, but I think that's the biggest reason. Yeah. Do I have plans to open source a smart lens tool? Yeah, it could be possible. We're definitely going to look into it first to make sure that it's like super complete, because I think there are probably a few edge cases out there that won't totally catch. So we just want to keep running it internally to see how it goes. Has Gradle caught anything that Buck hasn't caught when developing locally? Caught is an interesting word. I don't think there's necessarily something wrong per se that like Buck does that Gradle isn't properly catching. But there are some scenarios where, for example, Gradle or Buck will fail when the other one succeeds. I think a lot of that has to do with like resourcing, like resources, and I think there are some also call-in bugs related to Buck. But I think that's basically the short answer. That yes, there are some things, and we've basically worked around them to make sure that it's stable on both. Yeah. Sure. So why do we use Ruby instead of like Gradle plugins for some of our like non-build related tasks? I think the reason is that we just have like a very strong Ruby culture at Airbnb, and so we decided to go with it. There's just like a lot of internal Ruby gems that we use as well, so it's just kind of to fit with the rest of the engineering culture. Yeah. Sure. So the question is, with our Airbnb Lite flavors, how does the modularization work in terms of like features? So yeah, each module is essentially its own feature. But each module is not yet their own light builds. So I think we combine. There's like a number of like basically subsets that you can use, right, to develop a single flavor. So it can include multiple parts of it. It's up to the developers to choose what they need. We don't generate these or anything like that. It's based on the developer to create the flavor or the light build for their own purposes. Do we have any performance testing in our automation process? There's no testing for that. I think in terms of performance, like measurements that we do, it's all within the context of either like an individual developer who's focusing on that, or within an experiment, and we just test the differences with the experiment on and off about like cold start times and time to interactive and all that. But yeah, nothing in terms of CI. Have you run into any limitations with Buck for library projects? I don't think so. Not in the recent time period. Maybe when we had first implemented, I was actually not on the team when we first started using Buck for development, so I can't comment too heavily. But so far, it's been running great for us. Yeah. Yeah. So the question was, what were some of the issues we had with using call-in with Buck? There are a number of issues. A lot of them are just simply like the certain like build tool steps were not yet implemented in Buck. So for example, like call-in annotation processors were not available for a really long time within Buck, and we essentially either waited for someone to work on it and avoided using those kinds of things within our project. And for a lot of these things like Cat, for example, they did build them out, and then we were able to upgrade our version of Buck and start implementing things with call-in annotation processors. But there has been areas where we have made committed changes to Buck itself to like fix some of these problems, or maybe fork it and do some sort of like hack to make it work. But yeah, there's many different ways that we've tried to solve this, either by waiting for someone to implement it or doing it ourselves. Right. So if you have changes in React Native code, or if you have changes in both Android and iOS code, then we run all tests for both platforms. Have there been difficulties going from one Buck version to the next Buck version? Yes, there have been. There's a lot of things that end up breaking, a lot of things that that we've had to work around. But yeah, the short answer is we've had some breakages here and there. And we essentially have to like submit a fix to it, or just wait until that bug gets fixed on Buckmaster or something like that. Yeah. Sure. Can I explain a little more about Hapo? I'm not on the team that actually built it out. I'm just kind of aware of what they did. But essentially, I think what it does is it renders each view or each like view component within our DLS system, and then does a comparison between how it looks like on master versus how it looks like in your PR. And it'll basically send you a link with all the differences, and you can visually scan through, like, this is how the component looked before, this is how the component looked after. I think it'll even like highlight the part of it that actually changed, and then it's just kind of for you to be able to like mentally say that this was intentional and this is fine. Otherwise, you go back and check out what went wrong. The output's like in this really like nicely formed just like UI comparison. So it'll actually like render the views for you and then point out which part of the view is actually changed. Yeah. How does it render those views? That I'm not too sure about. Cool. Well, if anyone has any other questions, you can come up to me. Otherwise, we can probably just end early. Thanks so much, everyone, for listening.